Projecting Communication Diagram, or UML, from SBC Process Algebra. I'm Dr. William S. Chow. Chapter 1, SBC Process Algebra is the meta model of UML. That means SBC Process Algebra is able to ensure consistency between UML different diagrams because SBC Process Algebra is the meta model of UML. Then communication diagram can be projected from SBC Process Algebra. So we would say communication diagram actually is a projected view of the SBC process or a system. Chapter 2 introduces SBC Process Algebra. SBC stands for Structural Behavior Collections. And SBC Process Algebra is the only formal language to integrate the structure and behavior of a system. Since SBC Process Algebra is a formal language, let's now talk about its entity, its syntax, its semantics. SBC Process Algebra uses many entities such as operational call or operational return formula, and operational name, parameter list, such and such. An operational formula is used to completely describe an operation. There are two kinds of interaction in SBC Process Algebra. Type 1 interaction is an interaction between an outside environment actor and the COE object. Type 2 interaction is an interaction between the caller object and the COE object. SBC Process Algebra uses the 3 BNF rule to describe the syntax of the language. With the syntax description of the language, then a system is modeled by SBC Process Algebra as n IFD, with each IFD is represented as G11 prefix, A12 prefix, A13, such and such. SBC Process Algebra uses the transition rule to describe the semantics of the language. For example, prefix transition rule and summation transition rules. With the transition rule, we then have the transition graph of a system, shown as in this figure. A system will have many IFD. With the transition rule, we also can have the transition graph of an IFD as shown in this figure. A transition graph is described by the transition relation T with 3 attributes. With further extension, we will have the transition relation rewritten as T relation with 6 attributes. Now let's have the summary of SBC Process Algebra. The transition graph is a single and only one diagram that SBC Process Algebra used to describe the semantics of an IFD. Chapter 3 is the final chapter. Chapter 3 talks about how to project a system's communication diagram from SBC Process Algebra. A system has many IFD, and an IFD transition graph is described by the relation IFD with 6 attributes. An IFD's communication diagram in UML is shown here. An IFD's communication diagram can be described by the relation communication diagram IFD relation with 4 attributes. Now let's see the projection algorithm. Because each system will have n IFD, therefore we will have from 1 to n looping for each IFD, and each looping will have the 2 steps. The fourth step is create a new relation called communication diagram with 5 attributes. The second step, we will insert the new record into this new created communication diagram by selecting 4 attributes from the IFD relation. And each IFD-I relation will have 6 attributes. Thank you for your listening. Bye-bye.